Hi class, today's lesson we will be looking at chapter 3. I'm going to talk to you about the learning curve. So I'm going to share my screen with you and we're going to look at Cengage first. I want to go over with you exercise 3-24 today. And this is working with the learning curve. And so we're going to be Sharon Glessing, the controller for Janssen Company. And we have noticed that the company faces a 75% learning rate for its specialty design. In planning the cost of the latest design, Sharon assumed that the first set of units would take 1,000 direct labor hours. She decided to use this information in budgeting for the cost of the total project, which would involve the manufacture of 16 sets. Direct labor is paid at $40 per hour. Complete the table below showing the results by row for total production of 1 unit, 2 units, 4 units, 8 units, and 16 units. Round our answers to 2 significant digits. Round cumulative time, total time answers to the nearest whole number. It's important that you pay attention to your rounding rules when you're doing this problem. When we're talking about a learning curve, what we are saying is basically that once we produce 1 unit, then the units that follow, we should be able to produce them at a little bit less time. It'll take us a little bit less time to produce those units because we've got some experience in producing those units. So this company is using an experience rate or a learning rate at 75%. They told us that if we calculated the cumulative average time per unit in hours for 1 unit that we're manufacturing, it was going to take 1,000 direct labor hours. That was a given amount. So if it takes us 1,000 direct labor hours and we're only producing the 1 unit, 1,000 is also considered to be the cumulative total time in labor hours that it takes us to produce that 1 unit. Now, what happens with cumulative number of units is we double the units. Notice we went from 1 to 2, we doubled it to 2, and we're going to put down the information for that. Then we're going to double it again to 4 units, and we'll double it again to 8 units, and we'll double it again to 16 units. So each time we're showing that the units are doubling. And when they double, what that means is the first unit took you 1,000 hours, but the second unit would only take you 75% of that 1,000 hours. So the second time we made the units, it would be 75% of the amount of time that it took to produce the first units. So what I'm going to do here is I'm going to put in my calculator 1,000 hours is what it takes to produce 1 unit. But the learning rate is 75%. So when we get to producing 2 units, the second set of units, then we would multiply this 1,000 times 75%. And that will give us 750 as the amount of cumulative average time per unit in hours. We are manufacturing 2 units. So if we take 2 units and we multiply it by 750 hours, the cumulative total time then would be 750 times 2. which is 1,500 hours. So it takes 75% of 1,000 hours the second time we start to produce those units. 75% of 1,000 is 750 hours. Then we will multiply the 750 hours times 2, and that will give us the cumulative total hours. The 750 has to be multiplied by the cumulative number of units, which is 2 in that case, which will give you 1,500 cumulative total time labor hours. The next set that you're producing is 4, is the cumulative number of units. So we're going to take what it took us previously, which was 750, and we're going to multiply that by 75%. And what that will give us is 562.5 hours. Now it tells you to round your hour answers to 2 significant digits, and then round the cumulative total time answers to the nearest whole number. So what they're saying is we can round this column to 2 digits. So in other words, the $562.50, excuse me, it's not dollars, but it's units. It's hours per unit that we're talking about here. So 562.5 hours is okay to put in here because we're rounding our hours to 2 significant digits. So it just carried it out 1 digit, so we'll use that. Then what we'll do is we'll take the 4 cumulative number of units and we will multiply it by the cumulative average time per unit in hours. So this times 4 will give you the cumulative total time in labor hours, which is 2250. Moving to the next set of cumulative number of units is 8 that we're talking about this time. What we're going to do is we're going to take the previous cumulative average time per unit in hours, and we're going to multiply that by 75%. So 562.50 times 75% will give you 421 hours, 0.88. I would round that to 2 decimal places because they tell you to round your hours to 2 significant digits. So I'm going to clear out my calculator so I can make sure that I calculate my cumulative total time and labor hours correctly. Since I rounded it here, I'm going to put the new rounded figure in, and I'm going to multiply it by the cumulative number of units, which is 8. And notice that gives me 27,000 hours. On this part right here, they wanted you to round to the nearest whole number. So the whole number here is 27,000. For 16 cumulative number of units, I'm going to first have to take 75% of what the amount of time, average time per unit in hours was previously. So I'm going to put in 421 hours, 0.88, and I'm going to multiply that by 75%, the learning curve. And this time, it's going to be 316 hours, 0.41. And again, we can round to 2 significant digits, so I'm going to just leave that as it is. Then I'm going to multiply this amount by 16, and that will tell me the cumulative total time and labor hours that would be spent producing the 16 cumulative number of units. And again, we have to round this to the nearest unit. So it's going to be 5,063. I'm going to check my work, because if you don't get this part right, you're not going to get the second part right. And it looks like I've multiplied something wrong here. So let me go back and pick up $421.88. And I'm going to multiply this by 8. I was way off. Make sure you round to the nearest unit. So 3,375 would be the nearest units. Okay, so it looks like we're okay so far. And so this is just a table showing you the results by row for total production of each of these units. In the next part of this, it's asking you, what is the total labor cost if Jansen Company makes 8 sets or 16 sets? So this is the cumulative total time. And if we're looking at 8 sets, the cumulative total time is 3,375 units. So I'm going to round this figure off to 3,375. I'm just putting in what we did here for the 8 sets. So 3,375 is going to be multiplied by the direct labor that they pay per hour, which was given to you at $40. So we're taking the cumulative total time for labor hours. We're multiplying it by $40, and that's going to give us the total labor cost for 8 sets, which is $135,000. For 16 sets, we're going to pick up the 5,063 hours. We're going to multiply this by $40 that was given. The direct labor per hour is $40. And that's going to give us $202,520 as the total labor cost for 16 sets. It might be a good idea to check your work to make sure your math is correct. All right. In this next part, it tells you to use a logarithmic function, and you have to use Excel to do that, or that's what I would suggest you do, because it makes it easier for you to do that. So Again, pay attention to the rounding rules. They want you to round your hour answers to 2 significant digits. So basically, we're doing the same thing that we did before, but if you'll notice, instead of having doubling the sets that we're looking at, they're giving us each number as a set. So each one of these units they're giving you, notice 3 is missing from above. So this was wanting you to find 3. And so again, it's easier to use Excel to calculate that logarithmic function. And they want you to round your cumulative average time per unit in hours to 2 significant digits. And your cumulative time has to be rounded to the nearest whole number, just like we did above. But then they've added a new column asking you for the time that it takes to produce the last unit. And so when we start this, we're going to start out with 1,000 hours because this was our first unit. And the cumulative total time is going to be 1,000 hours. There's no learning curve that's applied to that. So the time for 1 unit has to be 1,000 hours. And I'm going to go ahead and check my work with that. And on the second part of this, I'm going to go ahead and, because we've got part of it finished here, it's going to be the same since it's 2 sets, is 750. Remember, we got that 750 hours by multiplying the 1,000 times 75%. And then we multiplied 750 times 2 to get the 1,500 hours. Notice it starts out being exactly the same. And what I want to show you here is the time for the last unit. So let me pick up my calculator again, show you how we're going to calculate that. We're going to take the cumulative total time that it produces for 2 sets. The cumulative total time and labor hours for 2 sets is 1,500. I'm going to subtract that from the total labor time that it took, the cumulative total labor time that it took to produce 1 unit. And that gives me the time for the last unit would be 500 hours. And this part right here, we don't have up here, obviously. So we need to be able to calculate what happens in part 3. So now I'm going to take you to my Excel spreadsheet where I've got the results of cumulative units number 3. I'm going to show you how to get the results for that using Excel to use that logarithmic function that they're asking you to do. It's just easier to use Excel to do that. So I'm going to stop sharing for just a minute. And I'm going to share my screen with you for Excel. So you should see in Excel now what I have written in the way that we started this before. Notice the cumulative number of units for 1 is still 1,000 hours. The cumulative average time in unit is 1,000 hours. The cumulative total time in hours is 1,000 hours. And the time for the last unit would be 1,000 hours. For part 2, we've written in 750 here, which came from multiplying 1,000 hours from the first set times 75%. That 750 times 2 would give you the cumulative total time in hours. And then what I'm going to do is I'm going to put a formula here where we are going to subtract our cumulative total time in hours for 2 sets from the 1 set, and that's going to give me the 500. That's what we had already written down in Cengage that we did just a few minutes ago. Right here is the formula for the logarithmic formula for determining the cumulative number of units for set number 3, which we're going to do in just a second. So let's go ahead and look at this formula and see what we can do to put this formula in. And so I'm going to simply put in an equals mark, and I'm going to do a capital L, and you can also click right here and get it. I'm just going to type mine in, and there you see this is in parentheses. You need to put in the learning curve percentage. So I'm going to put a parenthesis here, and I'm going to put in 0.75 because it was a 75% learning curve. I'm going to enclose that in parentheses. And then what I'm going to do is I'm going to divide this amount, hit my divide key, by, and again, I'm going to put in the letters LN, and then I'm going to put in parentheses 2, because we're, excuse me, there's got to be a 2 there, 2, because we're doubling the items. So this is the formula that you would record for this. So I'm going to hit enter here, and what that gives me is this value. This is the value of Q. Now what I'm going to do is I'm going to put in that I want to do 3 sets. And 3 sets is a little bit harder to find mathematically, so that's why we're going to use the formula here. And so what I'm going to do is I'm just going to copy that formula on down. We're going to put in everything that we had to put in. So I'm going to copy this formula down like this. And then right here, you're going to need to write in another formula that will calculate the cumulative amount. And if you want to, you can look back at your textbook on pages 112 and 113. This is how they're showing you about this formula here. And so in this cumulative average time per unit hours, we have to put in another formula. And this formula is equals, because there were 1,000 hours of cumulative time, we're going to put in the cumulative time for 1 unit. And then we're going to multiply that, and we're going to put in the formula power and I'm just going to type all that in because this is one way of doing it. And then I'm going to put a parenthesis in and then I'm going to put in what I have in cell A7, which is the 3 there. I'm going to put in my cell number for this so it'll calculate everything when I'm copying this down. I'm going to put a cell address A7, and then I'm going to put a comma, and I want it to calculate through F7. And let me move this so you can see. I don't know if you can see that toolbar or not, but I can. F7 is getting it by this formula right here. So we're going to put in a capital F, and 7 here, and then I'm going to enclose the parentheses there, and I'm going to click enter. And what that does is it tells me what the cumulative average time per unit in hours is. Because this was not doubled, we have to figure it out by this formula here. All right, and then in the next formula, what we're going to do is we're going to do just like we did before. We're going to take the cumulative number of units and multiply it by the cumulative average time per unit in hours. So I'm going to create a formula to do that. I'm going to click on my 3, A7. I'm going to hit multiply, and then I'm going to click on this figure right here. And what it will do is it will give me the total cumulative time in hours. And then because I had put a formula in here, I can copy this all the way down, and it'll put in the amounts for me as we go through this. So the next thing that you would do is you would put in 4 here. Copy this formula down, and copy this formula down. And so every time you put in the cumulative number of units, it just fills in for you. So the next thing they wanted was 5 and 6. So once you get your formulas entered in, the rest of it is pretty simple. You're just going down, putting in the information that they wanted you to do. And so they really just wanted you to do 16. I left off 9 here, sorry. So that'll make things wrong there. So let's put this in correctly. 10, 11, 12, 13, 14, 15, and 16. All right, and so what you would do is you would just take the information from this and plug it into Cengage. And so I really don't want to take the time to do that. I think that you understand how you would do that, but you go back in 3 and you put in this information here as to what they wanted. And this will easily calculate everything for you if you know to put in those formulas. So this is the formula to put in to find the value of Q, which is your learning curve. Put that in first and click and drag it through the number of sets that you're producing. You could have already written in this right here, 1, 2, 3 through 16, if you wanted to first, but you've got to put this formula in here, and then you need to make sure that you have this formula in here. And I don't think it would have been a problem if we put it up here and copied it all the way down. It should amount to the same thing. But this is the formula that they had you doing for part 3, because it comes up a little bit different here. Instead of taking 750 and multiplying it by 75%, because there are 3 sets, it comes up different. So that's why you have to use the formula here. And then in this one, of course, it's this times this, like we were doing before. And then this minus this gives you this. And so if you'll put those formulas in and you just click and drag it down, it fills in everything for you pretty quickly. And so again, this information is over on page 112 and 113 of your textbook. I just wanted to show you how to do it again. All right. So the rest of this is going to be a review for you. So let's look at what they have for us in exercise 3.26. It's really a multiple choice question, but what I decided to do was to go ahead and show you the long way of working this out so you'll understand what's going on with exercise 3.26. What I did is I just copied 3.26 in here. We're going to be the Starling Company, and we're manufacturing one product with a selling price of $18 and a variable cost of $12. Starling's total annual fixed costs are $38,400. If operating income last year was $28,800, what was the number of units Starling sold? You really have to kind of work backwards at this, and this should be a review for you. We covered this in ACC 121. It's a variable costing income statement that we're preparing. And notice I've broken it down into per unit. I made a table for this. Per unit cost, number of units, and dollar amounts. And I started with what they had given us. The sales was given at $18. That's the selling price. We don't know what the number of units are. So I'm going to take all this out for just a second and show you how we could arrive at what they're asking us to do from the information that we have here. I'm going to take this one out too. So what was given to us was the selling price per unit. One product has a selling price of $18. Your variable cost per unit was $12. And what you have to find is gross margin. And to find gross margin, what we would do is we'd take our selling price and subtract the variable cost from that, and that will leave us with our gross margin. Our fixed cost were $38,400. That was given. Our operating income was $28,800. That was given. So if you understand that sales minus variable costs gives you the gross margin, and sometimes we don't call that gross margin there, but we call it the contribution margin. You might remember it as that from ACC 121. So that's the contribution margin. Then we're going to subtract out our fixed cost, and that will give us operating income. Well, these figures were all given to us. 18 and 12 was given to us. 38,400 and 2,800, 28,800 was given to us. So we had to find 6, and you do that by subtracting 12 from 18. That's how you get the 6, which is our contribution margin. Our fixed costs were given, our operating income was given. So if we want to know what the dollar amount of our contribution margin is, since we were given our operating income and our fixed cost, we can find that. What I'm going to do is I'm going to enter a formula for that. So in Excel, you have to put equals to enter a formula. I'm going to click on my operating income. I'm starting from the bottom and working backwards. I'm going to add to it my fixed cost, and that will tell you what your contribution margin would be. If you know what your contribution margin is, and you know what your contribution margin per unit is, you can find the number of units. I'm going to create a formula by hitting equal. I'm going to put in the dollar amount of the contribution margin, and I'm going to divide it by the unit cost of the contribution margin, and that will tell me how many units I had to have in order to get this figure. If I know that I have 11,200 units, I can substitute this in here, and then I can find my dollar amount by multiplying 12 times 11,200 units. I could also find the dollar amount of my sales by putting in the number of units here and multiplying it by 18. So what they're asking you is, what is the number of units that Starling sold? The answer to that is 11,200. So you want to find your gross margin or your contribution margin first. And we can do that because we have enough information to give us our contribution margin per unit, and we can work backwards to get our contribution margin dollar amount. And then you're going to divide the gross margin dollar amount, or the contribution margin dollar amount, divide the contribution margin dollar amount by the unit cost. So that was this part right here, divide it by the unit cost, and that will give us the number of units. The number of units is the same for sales, your variable cost, and your contribution margin. But the answer to that is 11,200 units. And that's one way you can find this. So this should be a review to you. In exercise 3.27, there was also a multiple choice question. And so this was the question here. Allard Manufacturing Company has a billing department that is staffed by 4 billing clerks. So I wrote down the number of billing clerks first. And it says each clerk is paid $32,000 per year and is able to process 8,000 bills. So this salary per year is $32,000. The number of bills that each clerk could produce is 8,000 bills. That's what they told us. So what you're finding is available capacity first. You want to find the total available capacity, which would be found by taking the 8,000 units per person that the billing department was supposed to process the 8,000 bills per person. We're going to multiply it by 4 because there were 4 clerks, and that will give us 32,000 as the total capacity, which is 32,000 would be the number of bills that they would be able to process in a year. That's your available capacity. Then they told you that you processed 27,360. That's your used capacity. To find the unused capacity, which is what they wanted you to do there, you're just simply going to subtract the used capacity from the total available, and that will give you the unused capacity. So the unused capacity in bills that were not sent was 4,640. And so they did not meet their goal for whatever reason. This is unused capacity. So the total available capacity is the total amount that you have available that you should have been able to achieve for a whole year. And that was, excuse me, I don't know what happened there. Delete that and put in the unused capacity. The used capacity that was given 27,360. And then this is found just by simply subtracting. Okay, so I've got it back in there the way it should be. So the answer to this problem is the unused capacity is 4,640. For exercise 3.28, it was another multiple choice question and was very similar to the one we just did. It says Allard Manufacturing Company has a billing department staffed by 4 billing clerks. Each clerk is paid $32,000 per year and is able to process 8,000 bills. Last year, 27,300 bills were processed by the 4 agents. And then it gives you this what if here. What if one of the billing clerks agreed to work half-time for 16,000? So what that means is if one of the clerks was working half-time, we only have 3.5 clerks, basically. They're still expecting each clerk to be able to produce 8,000 bills per year, per clerk. So we'll multiply 8,000 times 3.5, and that'll give you what your available capacity is. And since they only had 3.5, this time they processed 27,360 bills here. That was just put in right there. And then you would subtract the 27,360 from the 28,000 to determine what was unused. And so this is all that I want to talk to you about today. So I'm going to stop sharing this with you, and we'll see you next time. Bye-bye.